So what is PhysX and Apex? If you're not familiar with it, PhysX is our toolkit or middleware solution for physics that's used primarily for game developers. And on top of that, we will talk about it in a bit more detail later, but Apex is this framework we created because as we are deploying physics into games, we had an observation that we need to make physics more accessible to the people who create most of the content for the game, which is the artists and the level designers and those guys. So we'll get into those details in a moment. You guys already saw Dark Void and Metro, and there's a whole bunch of titles that are going to be using Apex and PhysX that's GPU accelerated that you will see coming into the future. The sort of those little symbols over there represent where PhysX is deployed. Actually, it's on the consoles, PS3, 360, on the Wii, and also on actually handheld platforms. All right, this kind of gives you a sense of the kinds of targets we have on the platforms for PhysX. So even 2D games that are on the iPhone can use PhysX, because physics is not just about 3D. You can even do physics in 2D. So actually, turns out a lot of game developers do use our PhysX solution for the iPhone, which is kind of cool. Next slide. Okay, so here's how a game developer can sort of take a look, or the view a game developer would have of the software stack we have. So as I mentioned before, we have different platforms that we deploy PhysX on. So you have sort of the GPU with the GPU accelerated physics, cool effects that you've seen on the various demos. There's your classic x86 CPUs, Intel, AMD, and so on. The Cell CPU on the PlayStation 3, PhysX works on that. Same thing with the CPUs on the 360 and the Wii CPU. And the layer above that is basically what the programmers. So a typical game developer has 2, maybe 4, up to 4 physics engineers. Their job is to put together all the physics effects, make sure that's working properly with the AI and the graphics. And so these are programmers. They use our physics SDK. And so there's a whole bunch of functionality in that physics SDK. There's rigid bodies that we talked about previously. Ragdolls are actually the guy who sits in the rocket sled is a classic example of where you use ragdolls. Soft bodies are things like cloth or paper, things that can deform. Force fields are where you want to sort of say there's a wind coming from here, or there's some impact happening here and there's generating an explosion. Those kinds of things. And fluids, of course, that's water and blobby blood, whatever, all kinds of fluid things that you can think about. So that's what the game programmer, the programmers, the physics programmers work at. The designers, on the other hand, they are not programmers. They are the artists, they are the level editors, and so on. And for them, it's really non-trivial to access. Since they cannot program, basically they have to work within the framework that the programmers created for them. The goal with Apex is to provide a framework that will allow those guys to actually use physics and actually quote-unquote program physics in a game. Next slide. So here's an update on where we are with PhysX and Apex. So we have a lot of adoption actually of PhysX, and we'll show you some numbers. We've made a lot of console improvements over the last year, up to 3x in some cases, more in actually some particular modules. The GPU physics part, the adoption is growing. You'll see games like Batman, Dark Void, we showed you Metro, there will be more games. But it's not, the standard actually, ironically, if you look at the profile of where physics is used in a typical game, the typical game does not have GPU accelerated physics. So a substantial majority of our physics customers are actually not using GPU physics. So it's not de facto, it's not standard yet. And we'll see how the things we're going to be doing to make that happen. Next slide. So just to give you guys a timeline of how sort of we've evolved the solution stack. So as you may or may not be aware, company which owned the PhysX brand and created the PhysX sort of solution was a company called GF. They had, in fact, a hardware processor called the PPU, PhysX Processing Unit, which is kind of like the GPU for physics. That was their sort of their idea. Unfortunately for them, that from a business point of view, that didn't quite take off. So we were in a position to acquire them, and it was a great acquisition for us because their software mentality was pretty much exactly what we wanted, which is we wanted the ability to have the ability to target multiple platforms, consoles, etc., but also target something like a GPU, which they had, which they call a PPU. It's very similar actually in many ways architecturally. So that was actually really helped us go from the acquisition, which was about February of 2008, to getting, even before Q2 of 08, we already were able to take their software, which was targeted for the PPU, and map that very cleanly or very efficiently to the GPU. So it was really worked out really well. And we took some of the existing content like Unreal Tournament 3, which had been written for the PPU, and were able to repurpose that to the GPU pretty fast, like literally in 2 months. And then the other part we focused on was to improve the console experience because, as I said, a big substantial chunk of our customers, or the people, the developers who use PhysX, actually targeted primarily for those platforms. So it's very critical for us to focus on that, because at the end of the day, if we don't get that adoption, the GPU is going to be sort of left behind if developers don't adopt PhysX to begin with. We then also added support for the Wii for the same reason, which is we wanted to increase the footprint of PhysX. And the interesting observation here is that other than the PS3, where we have a GPU, the other platforms do not have any NVIDIA hardware at all. The Wii or the Xbox or the iPhone, etc. So, but from a strategic overall picture point of view, it was very important for us to make sure that developers adopt our solution, and therefore it was imperative that we support these platforms. So we have invested substantially in those, supporting those platforms. The other thing we introduced about late 08 was PhysX SLI, which was basically the ability to run asymmetric configurations. For example, you can pair a GTX 285 with a 9800 GT. You can have the graphics done on the 285, and then the 9800 GT, which you might have in the old days sold or given it to your friend, now can be used to run physics. So actually, we even created a second life for some of our older GPUs, which is pretty cool actually. So soon after that, like I said, we announced we've been working on the solution that would enable more people to use more physics more effectively, and that was Apex, and we announced that at GTC in last year. The other thing we've been working on in Sebastian's group is plugins for Max, Maya, debuggers, and profilers, because all of this has to fit in a coherent way. All these tools have to be available for the artists and other people to use our physics solution effectively. And we will describe some of that, and in fact, we'll have a demo of that after this presentation. And one final bit we added was 64-bit support, because that was very important for a lot of our developers. Next slide. All right, so console. Again, we put substantial effort into our console product. We have a dedicated console team, actually, that focuses exclusively on PS3 and 360. And we made a significant amount of improvements in 2.8.1, which was released about late 08. And as you can see, we have, in some cases, we have made improvements up to 8 times on the PS. These numbers are for the PS3, but we have similar improvements on the 360. And the reason, again, like I said, we did it. If we don't do that, then physics adoption will not be as pervasive, and that would make the GPU physics part less likely. Next slide. Okay, so how has that resulted into success? So as you can see, this was independent websites have done surveys, and actually one of these websites, this is a very cool website. I recommend everybody to go there if you want to learn more about physics. It's not run by us at all. It's an independent website that collects all kinds of information about physics and physics engines in general. And they counted up all the titles that have shipped using PhysX and Havoc, which is the other leading middleware for physics. And there are some smaller ones, ODE, Newton, and Bullet. As you can see, we are way ahead. And that number has already been eclipsed. We are probably at more like 220 by now. So all the data there is a little older. The other thing was Game Developer Magazine did a survey of a lot of developers, and they discovered that, again, we are the #1 physics engine that is used by developers. So which is very good. Next. So why is that? And one of the reasons we have a lot of adoption is because of the feature set we provide in comparison to Havoc, which is our primary competitor in this space. As you can see, we have unique technologies. SPH Fluids is a very cool fluid algorithm. In fact, the guy who invented that algorithm is a key member of our physics team. If you guys are interested, I can later show you some demos using SPH, but you've already seen some of this in some games like that. So we provide features like that, which Havoc simply does not have. We have the turbulence feature, which you saw, the gun effect, and the jetpack effect, the duck void. Again, Havoc does not have that. And of course, we have GPU acceleration, which Havoc does not support. So there are many different sort of things we provide that Havoc simply does not have, at least not today. And that's one reason why our adoption rate is higher than theirs. Next. So what is Apex? So again, as I mentioned, the hard part.
I think there's a question.
Oh, sorry. Oh, it's basically what you want to do is, if you have let's say a wall, and there are two ways. Sort of, if you have a gun, you can have the wall be blown up. Right? The interesting problem with that is, if you blow up the wall, you're going to create a hole, and that means you have to update the AI to actually be able to reroute themselves through the hole. But let's say you don't want to do that because that's going to change if as a game developer don't want to mess around with the AI, you just want to provide the effect of physics. So what we provide is a mechanism to chip away at the wall without actually creating a hole through the wall. So you still get the effect that when you shoot the gun at it, you're interacting with the wall, as opposed to many games where you shoot your bullet and nothing happens. So you get the plausibility of physics without actually having to pay the price of having to recompute all of your stuff. That's what we call it hierarchical chipping. Of course, nothing prevents you from blowing. You can also use physics to blow a hole, but then it's up to you as a game developer to go figure out your AI, your path planning, and so on. Which, as you know, on Fermi, you can do that really well with AI. So sorry, previous slides. All right. Any other questions? Sorry, please stop me anytime. So what is Apex? So as I mentioned before, the realization we had working with developers was the bottleneck in deploying physics is not the physics programmers, it's actually the artists and the level designers. And the reason for that is physics is done at the code level. It's actual C++ code, and artists and level designers don't work at that level. So we wanted to give a mechanism for the artists to actually put physics in game, to add physics content, without having to learn how to program. And so Apex was kind of born out of that. The other sort of thing we realized was for NVIDIA to succeed in this multi-platform mechanism, most developers don't want to take content and recreate new content for higher-end machines, right? For example, PC, typically, your high-end PC with 3-way SLI with 3 Fermis and Core i7 is not something they may target simply because if they make really high-end content, how do they scale that down to something like a console, like PS3 or 360? So we had to provide a mechanism for developers to make a scalable physics solution. So you can have high-end content for high-end configurations and relatively low-end content for the lower-end configurations. So how do we do that? And then the dynamics part of it is, of course, the physics part, and you want to maintain the same behavior, roughly speaking, across all these platforms. You don't want radical differences between the physics on the high-end PC and the console, because that creates a QA and content nightmare for developers. So all these issues that were sort of repeatedly we saw when we were working with game developers to deploy GPU physics. And so we ended up with this thing called Apex, and the idea behind it is basically we provide a mechanism and tools to author the content in such a way that it is scalable, it is deployable by artists rather than by engineers, and along with it is a runtime that allows you to, on the fly, essentially say, oh, I'm running on a high-end PC, therefore I want to have the highest knob. So basically artists are provided with sort of these knobs or tuning parameters that you can create more high-end content depending on how powerful the platform you are. And we'll see some examples of that. Steven shows the demo. Right? So the other critical part of making something accessible to artists is you have to work in the tools and the workflow that they are familiar with. Like I said, artists are not going to be writing C++ code. They typically use the digital content creation tools like Maya or Max and Softimage. So Apex and Physics integrates completely into all of these tools, and we'll show, in fact, the demo will be on 3D Studio Max using Physics and Apex. SpeedTree is one of our partners that actually is the de facto standard for generating vegetation, which is trees, foliage, all of that. It's used in God knows how many games. And so Physics and Apex are completely integrated into SpeedTree for a module which we call Apex Vegetation. And again, this is where you can create trees where you shoot a gun at it, the tree will break, the leaves will fall physically correctly and will interact with the rest of the environment. Next slide. So again, so what you want to provide is the mechanism. So where a programmer might look at a physics as small pieces of rigid bodies working together. For example, a collection of bricks. For artists, you actually want to think top down and say, oh, I want to put a destructible bunker here. And the idea is that the artist takes his level editor or his DCC tool, brings in his art assets, marks it and says, oh, this is destructible. Then throws in maybe a tree or two through the SpeedTree solution. Maybe puts in a cloth banner or so. And so in the level editor, you can basically compose physics without having to go write C++ or write a whole bunch of code to make it all work. And then just literally says go, and it all simulates correctly. So that's sort of the key idea behind physics, behind Apex. And again, as I said, so we have integrations into Maya and SpeedTree and Soft and all the DCC tools, Max. So the first version of Apex, which we will release publicly at GDC in beta form, are 4 modules. But actually, interestingly enough, we have already used Apex in Batman, in Dark Void, in Metro, and some of these other games, which allowed us to actually validate that what we were building is the right thing, and that we are actually, that this framework is actually useful and can be used for artists. That was very, very useful for us to get that validation. I believe the next part is for Steven to force you guys to get out of your comfy chairs and walk over there and show you guys a clothing demo. Maybe you want to say a few words first?
Yeah. So what we're going to show here is a quick demonstration of the Apex clothing module in the 3D Studio Max. The Apex clothing module really provides hyper-realistic clothing simulations. It's capable of simulating types of clothing such as skirts, shirts, jackets, robes, even hair to some extent. So about a 15-minute demo over here. So you might want to bring your chairs over to.
All right. So this is the musical chairs part. We're going to have you all move over.